Welcome to the venting course. This is one of your G2 training courses. And in this course, we are going to use Unit 22, which is called venting. And this is going to be the only book that only textbook. We're also going to use the code book along with Unit 22 in every lecture. So this is the first lecture of the course, and we're going to talk about Chapter 1, venting systems. And chapter 1 is probably the smallest chapter in number of pages, but because it contains a greater number of new concepts and new terminology, we are going to spend a little bit of more time per page, if you wish, on this chapter. And the objectives, if you look at page 8 in Unit 22 in the 7th edition, at the end of this chapter, you will be able to describe vented appliance categories. That's what we're going to do the last thing. Review draft definitions and effects. We're going to start with that because we need to learn what draft is before we can talk about anything else. And then describe venting system components. Hopefully at the end, you will be able to tell me that this is a vent connector versus a main vent, or this is a C vent versus a B vent, or what are the heat loss places for a venting system and whatnot. So again, we're going to start with the draft definitions and effects, because that's how we're going to gain our knowledge of the terminology to be able to discuss this matter or even think about it. So, in your code book, section 3 of the code book is definitions. And by code book, I mean B149.1, natural gas and propane installation code. And in the definitions under D, you can find draft. And as you can see, there are one, two, three kind of definitions for draft, different types or kinds of draft. One is a chimney draft, obviously the available natural draft of the chimney, measured at or near the base of the chimney itself. All right. I don't expect that you make sense of this sentence right now, but eventually things will get clearer and clearer. Mechanical draft uses some kind of a motor, electrical motor, basically. We call it a venter motor, and based on where the motor is located in relation to the ignition point, if it is prior or upstream from the ignition point, we call it a forced draft. If it is downstream from the ignition point, we call it induced draft. As simple as that. And if we're not using a mechanical draft at all, we call it natural draft. In natural draft, instead of the electrical power that moves the motor, that moves the fan, that moves the gases, we use the power of the heat generated in the combustion itself to move the combustion products, which obviously are going to be very, very hot in this case. In previous courses, you've learned that you are going to need both, combustion air and fuel gases. You need both to go into the combustion product, and then you're going to add your ignition there to complete the triangle, the fire or flame triangle, sustainable combustion triangle. To have that heat generated at the rate that you need it. In some places, you will need 100,000 BTUs. In some places, you will need 100 million BTUs. Depends on your application. The more BTUs per hour you need, the more volume of gas and combustion air are going to flow per hour into the combustion chamber. I think the question then becomes that, okay, so say, for example, we had done that for a while, and we have filled our combustion chamber with, at the top of it at least, with combustion products. Then what, right? Where are those combustion products going? Obviously, in this case, they are, pretty hot, so they are gonna rise. We said there is no motor, so heat rises and they're gonna go up. And then what? Going up where, right? They are going into what we call the venting system. That's it. So you have your, you know, supply of air and fuel gases. You have your combustion going on, right, in the combustion chamber, and then you have your venting that is going on here. Bonus thing, this here is called the appliance breach, by the way, because that's the point where the flue gases or the combustion products are breaching the appliance to the outside. So, in other words, let's think about operating an appliance in 3 consecutive phases. Okay, so 3 consecutive phases. Air and fuel gas go in. If you remember, we did this part last semester and we called it pipe sizing. We learned how to size the natural gas or propane um, supply system in diameter and length and whatnot. This, whatever air required, combustion air required, is going to be chapter number 6 in unit 22. So at the end of this course, we're going to learn how much air we're going to provide per BTU we burn. So combustion, you've learned so much about combustion in Unit 3, for example, in G3, in Unit 9, it was all about introduction to gas appliances and whatnot. And of course, this course is going to be about venting. And I need to emphasize one factor that we're not going to learn about all kinds of venting. We are going to learn about category 1 appliance venting only. Okay. And what does category 1 means versus category 2 and 3 and 4? We're going to talk about it at the end of this chapter. All right. So let's make a definition clear. Draft is the flow of air or combustion products or both through an appliance and its venting system. So why do we say venting system and not say just venting or say, for example, the chimney or the draft or just we say system. We say system. It feels very formal. It feels like someone has to design it, and that's exactly why we say system, because someone has to design it, and someone has to be able to troubleshoot it if it doesn't work properly. And here is an image depicting an open fire pit. Obviously, we cannot precisely say when humans created, or invented fire as a technology, and we still enjoy making our fire pits and sitting around it. Uh, I personally haven't seen anyone who doesn't like watching a nice fire pit going on. However, the fire pit itself is quite different than the furnaces and the boilers that we work with and some other more complicated and sophisticated appliances. And why? Because in a fire pit, you have your solid fuel there, right? And you have your combustion air coming in from all directions, and then you have your draft or your combustion product, leaving, going in all directions. It will certainly go in the direction where you're sitting in your chair comfortably and having your drink, and it will go in any direction basically that the wind blows. And if there is absolutely no wind, if there is absolutely no air movement, you can see that combustion products are going to rise up because heat rises up. Now, the thing is, even this is rudimentary. This a very beautiful. I'm trying to find something like this for my backyard actually. So this is a very beautiful. Um, let's call it an appliance because it's burning, fuel, and it's providing heat in addition to it being very beautiful ornament there. So it is very, I'm saying very rudimentary and basic compared to obviously to the appliances that we use. However, it is different than a fire pit, open fire pit. It has this thing here, this cylinder, right? And funny thing about that cylinder, it's not a conspiracy theory, but you're going to find it everywhere. You know, I'm betting that the image on the right is uh, something that is built for more practical reasons. It doesn't look something very decorative to me. I think it is built for maybe cooking, possible. But the question stands: Why do we use that cylindrical shape? Why do we go to additional cost and effort and time to build that cylindrical shape? That's the question we're going to ask, and that's the question that is going to lead us to the starting point of understanding how draft is uh, generated and maintained, most importantly. Here are three completely different applications of heat generation. Sorry, the two of them are residential, but maybe three different applications of, uh, I would say, venting systems. So in this case, this chimney, it's not cylindrical, but still falls under that general description of a conduit that taking the combustion product to the atmosphere. So my question would be, why do we need all that? Why don't we just get rid of all that and make an opening here and let the combustion products go out from there, right? It's practical. Maybe you're gonna say, no, that looks better. It's easy on the eye. In residential applications, we spend money on things that are beautiful. Okay, how about this? These are chimneys, and I am going to bet that they cost a lot of money. Why did whoever build that build those chimneys? It cannot be. You cannot, say they are built for their good looks because they do not have good looks, and also they are costing money for someone who's probably trying to save money. It looks like very industrial application, and when you're building your industrial complex, you don't want to spend more money than it is necessary. So there is a practical need for that, 100% sure. In the third picture here, you have your two vent connectors, and then you have your main vent, right? Vent connector basically is that piece that connects the appliance to the main vent. This is being the main vent going to the roof. Well, in this case, the application is pretty simple. I'm not gonna dump the combustion products in the house. As simple as that. I can explain it here. That's why I'm trying to find a way to build something like a pipe that will take my combustion products from my appliances indoors to the outdoors, right? So let's have a look at then, let's take a step back, have a look at the bigger picture. What are vending systems? What are the functions of what do we expect from the vending systems? Only three things. It can boil down into three things. Number one, completely vent the flue gases to the outdoors without spillage into the building. Well, yes, please. Uh, Flue gases are the combustion products and the air coming from the combustion chamber. Uh, Dump them all out. Don't spill any of that in back into the building. That's absolutely unacceptable. Secondly, effectively vent at a rate that ensures the proper operation of the appliance. In other words, if I need to burn 100,000 BTUs per hour worth of fuel, my venting system should be able to remove that much of combustion products per hour. Okay, so whatever that your appliance is putting out in terms of its capacity, the venting system should match that capacity or be a little bit bigger, just slightly bigger, not smaller. And then operate safely in terms of fire. Well, yes, please, obviously. We don't want to be dealing with hazards there. So those are the three things that you always think about. Remove everything outside. Have the capacity that matches the appliance. And whatever you're doing, do it safely in terms of the venting temperature wise and of course corrosion wise. A lot of venting systems are made of metal, and unless they are made of stainless steel, some of them are, uh, but others are just galvanized, steel or whatever that can be corroded. Some of them are clay, or lined with a clay tile. Some of them are brick. Of course, those are going to deteriorate in time and create all kinds of hazards or unsafe operating conditions. Now, fundamentally, we want to talk about the diameter of the venting system. We're going to talk about the height of the venting system, and we are going to talk about the material of the venting system. If you decide all three of those, you have designed a venting system. That's the bottom line of this. Now, let's just say that the diameter and the height are what we call sizing of the venting system. Material is going to be given to you. It's not so. In vent sizing, no one is going to ask you what material should we use with this. It is going to be given to you. And to understand better, the only time you're going to be asked what material to use is either it is a rule, like for example, recessed wall heaters shall always use type BW venting systems. Why? Well, because the code book says so. Okay. Or, for example, if you have if you're going to use system 636, there are 4 different categories of it depending on the temperature of the flue inside of it. Then you can decide what to use. But usually material is given to you in as far as the scope of the sizing in unit 22. You're going to be told it's either a chimney, tile line chimney, or it's going to be type B double wall vent. That's it. You're not supposed to be guessing what material you're going to use. So in other words, to determine all three, you need to understand temperature and pressure. Of the draft and the flue gases. That's what you need to do. Once you understand that, you know what system it is. You have already designed it. And what we're going to do in the next video is we're going to talk about the details of those temperatures and pressures and what creates the pressure. We know what creates temperature, but what creates the pressure and where does the pressure go?